Hello and welcome to SudoKanard. We're here to solve this Kropki Sudoku by Dutch author Richard Stolk. It was featured in the latest Sudoku Grand Prix. It was worth 53 points, which is kind of middle of the road in terms of difficulty, and yet I know some people had real trouble breaking into the puzzle. And I remember I had some hard time during the contest at some point, but I managed to find a break-in. I just hope I'll be able to find it again. So the special rule here is that whenever you have such a black dot between two cells, then one of the digits is double the other. When you get a white dot between the cells, it means that the digits are consecutive. And most importantly, all possible points, all possible dots have been given, which means that here those digits are not consecutive and none of them is double the other. So where do we start when you have no given digits? Well, something you have to appreciate is that those three black dots in a single row mean that one of them will contain 1 and 2, another one will contain 4 and 8, and another one will contain 3 and 6. So those 6 digits will have to be those. They can never contain 5, 7, 9, which means that 5, 7, and 9 are in those cells. And at some point we will have to determine which of those pairs goes into which domino with a black dot. Now, how do you continue with this? Well, the next thing you have to appreciate is that wherever you put the 9 here, you will put an 8 next to it, because 8 is the only digit that is consecutive with 9. The digit consecutive with 7 could be 6 or 8, but 8 has already been paired with the 9, so the digit next to the 7 will be a 6. And then the digit next to a 5 could be a 4 or a 6, but 6 has been used by 7, so the digits next to 5 will be 4. And it means that this can only be 1 and 2. This is something that's important. Another thing that is important is that 4 and 8 next to each other need a black dot, and seeing that there is no black dot here, this can never be 4 or 8, because if this were a 4, then it would be next to the 8 with a black dot. So that has to be a 6, and we say that 6 had to be with a 7. So that's something. So that's for a start. So we know that this is 3, 6 or 4, 8, and the same is true here. So that 1 and 2 go there. So how do we decide? So this is either 4, 8 pair or 3 and 6 like this. And we can see that 1 and 2 are in this area. So they could be here, or we could have one of the digits there. So let's imagine that this is 1, then 1 goes, this is 2, sorry, then 1 goes there, but 1 has to be consecutive with the digit, it will be 2. So that is not happening. So we could also have 1 here, in which case this is 2 and 3. So that is a possibility, in which case this can't be the 2, in which case this can't be the 2 next to the 1, and that's a 2, and this has to be 8 and 9, and then this is 4, and then this is 5, but this breaks because there is no white dot in here. So this is an option that doesn't work, which means that this is a 1-2 pair. Now this was a little difficult, I must say, but there was, well, not sure how to do things differently, to be honest. And then something I'm seeing is that this digit here can never be a 3 because there is no black dot, so that 3 must be in here. If 3 is here, then, well, 3 is here. But if 3 goes there, you see that this is never a 4. And this is never a 4 either, because there are no white dots. So that those have to be both 8s, which doesn't work. And this proves that that is a 3. And this is 6. So that this is a 4-8 pair. And next, what do we have? So now 3 is not here. 3 is down there, and we need a 3 somewhere in here. So now we must appreciate the fact that the pair that is not here has to be in those two cells. So with 4, 5, and 4, perhaps I can do something better here. I'm not sure that this part, I'm not sure this is the right moment to disambiguate. Well, what is the next step? So I said, yes, I said this can't be a 3 because there's no black dot. It can't be 5 or 7 because there is no white dot. So this has to be a 9. And here we get 3, 5, and 7. Right. So now those 3 digits are also 3, 5, and 7, but we had 3 and 7 here, so that this is 5, and this is a 3, 7 there. But now 5 can't be next to the 4 without a white dot, so this is 8, and this is 9, and this is 5, and this is 4, and this is 4 as well. 4 can't be next to the 2 without a black dot, so that's a 1, that's a 2. 2 can't be next to the 3. And I think this is it for this part. 4 can't be next to the 3, so that's a 7, that's a 3. 3 can't be next to the 2. And here we need 6, 8, and 9. 6 and 8 can't be next to the 7, so that's a 9 next to the 8 with a white dot. And that's a 6. 6, 5 is not available, so that is 7, that is 8. And as you can see, once you've broken into the puzzle, the rest follows generally pretty easily. 8 can't be next to the 7 because of this, so that's a 9. And I said pretty easily, but it doesn't mean that everything is that immediate. So now we need 1, 2, 3, 9. This can't be a 9, obviously. Well, 9 is somewhere here, but it isn't that helpful. 7 is down there. Something of interest here is that we already have 3 odd digits. We will have another odd digit here and another odd digit there. So 7 is not available. So the odd digit here will be 5, and the odd digit here will be 7. So 7 will be with the 6, because 8 is not available. So that 5 will be with the 4. And that's, here is a 2. 2 can't be next to the 4. That has to be a 6, and that has to be a 5, because 7 is not available. So 1, 2, 3 go into those cells. 2 and 3 can't be next to the 4 without a dot, so that's a 1. 2 can't be next to the 1. And here, this is 4 and 8. 4 can't be next to the 5. It can't be next to the 7. This is 1, 3, and 9. 1 and 3 can't be next to the 2. 3 can't be next to the 4. And let's just ponder what is happening here. This doesn't use those digits, so it has to be 3 and 6. This is either 2 or 4, but 2 is not available. So this could be 7, 8, 9, or 5. No, 5 is not available, so this is 7, 8, 9. So that this is 4, this is 8. 4 is not next to the 2. 2 is not next to the 3, so 3 is there. 4 is not available, so that's a 2. And we need a 5 for the column. 8 by Sudoku goes there. It's not next to the 7. Here I need 1, 5, and 9. 5 can't be here. 5 can't be here, so that's a 5. So that's 1, that's 9. Here we need 2, 5, and 7. Because of that, 7 is here. 6 is, sorry, 8 is not available, so that's a 6. Here we need 1 and 4 because of this. This is 1, this is 4. 2 is next to the 1, and 5 next to the 4. We need 3, 8, and 9. Only 3 goes there. 8, 3 I said. 8 is not next to the 7, nor next to the 4. Here we need 1, 4, 8. 8 can only be here. 4 can't be next to the 8, so that's the 1. 1 can be only next to the 2. Here we need 6 and 7, so like this. That's a 9. The 3 can't be next to the 2 or next to the 3 for that matter. That's a 5. Here I need 6 and 1. Here I need 7 and 4. 4 is next to the 3, and that's a 2. So with those Kropki puzzles with the negative rule, once you've found a reasonable amount of digits in the beginning, the rest follows pretty easily thanks to the negative rule, most notably. But generally, the beginning can be a little tricky, and this is one way of doing it. Thanks for watching this video, and see you soon on SudoKanard.